Hello everyone, welcome back. In this video, we are going to continue chemical properties of metals. We have already learned about the physical properties of metals and non-metals, and I have shared the link in the description. You can check out that video also. Now let's start with the chemical properties of metals. So we'll learn about different chemical reactions and try to understand properties of metals, chemical properties of metals. So the first reaction is reaction with oxygen. So how different metals they react with oxygen. So first of all, we'll write the general chemical equation: metal plus oxygen. These are the reactants, and we will get metal oxide as the product. You can see on reacting metal with oxygen, we will get metal oxide. So let's take few examples now. Copper, which is a metal, when it reacts with oxygen, we'll get copper oxide. Since in reaction with oxygen, our product is metal oxide, so that's why we'll get metal oxide, which is copper oxide. So you can balance this equation, because all the equations, whenever you are writing any chemical equation, so you have to balance it. Now let's take one more example. Aluminium, which is metal, plus oxygen, so product it is confirmed metal oxide, so it will be aluminium oxide. So again you can balance this chemical equation. If we balance, we can see so this is general reaction. Whenever any metal it reacts with oxygen, we get metal oxide. But different metals, they react differently. They have different reactivities with oxygen. So let's discuss that now. Let's take the case of sodium and potassium. Sodium and potassium, they are the most reactive metals. Although they will give us sodium oxide or potassium oxide, but being reactive, whenever they react with oxygen, they can cause blast, which means there is a vigorous reaction between these metals and oxygen, which can cause, and this reaction can cause fire. So accidental fires can be there if sodium or potassium they react with oxygen. So due to this reason, you always have to remember one thing: sodium and potassium, being very reactive metals, they are always kept in kerosene. Why kerosene? Because kerosene, it will form a layer on the surface of the metal which will cut its contact with air. So if there is no contact with air now, so there will not be any reaction, and we can prevent the accidental fires in this way. So that's why sodium and potassium, they are kept in kerosene. So second metal which we are going to discuss is iron. So if you sprinkle iron fillings on a flame, it will burn. So iron fillings you have to sprinkle, only then the reaction is possible. It will not cause any type of firing or like in case of sodium and potassium, but this reaction, this will get burnt, iron fillings. So the next reaction, the metals which we are going to discuss is silver and gold. So these metals, these are least reactive. Least reactive means they don't react at all with oxygen, don't react. So there is no reaction in case of silver and oxygen. So this was about the different reactivities of different metals with oxygen. Now let's do the second chemical property of metals. So before doing further reactions of metals, let's try to understand few reactions of metal oxide. So metal oxide, we know how metal oxides are formed. They are formed by the reaction of metal with oxygen, and we have already done in the previous reaction. So here we are going to do reaction of metal oxides with acid and base. So we have already discussed in acids, bases and salts that metal oxides, they are basic in nature. But you have to understand there are few metal oxides that can show both acidic and basic nature. So oxides of zinc and aluminium, they show both acidic and basic nature. So such oxides, they are known as amphoteric oxides. So you have to remember this term. Amphoteric oxides are those oxides which show both acidic and basic character, and the oxides of zinc and aluminium are known as amphoteric oxides. Now let's do the reaction of amphoteric oxides with acid and base. So the reaction, it will be similar to reaction which we have already done in acids, bases and salts, and that reaction is neutralization reaction. So I have already shared the link. If you want, you can go through that video also and understand what is neutralization reaction. So let's do the reaction here. So metal oxide, because we are discussing the metal oxides of zinc and aluminium, so let's take aluminium. Metal oxide. So aluminium oxide I have to take, since it can behave both way, acidic and basic also. So let's do its reaction with acid first, because we are doing the reaction with acid and base. So now you are reacting metal oxide with an acid. If you are reacting it with the acid, so it will behave basic. It will show basic character. So here one general thing you have to remember, metal oxide plus acid or metal oxide plus base, the products which you are going to get is salt plus water. So water you can write first, and remaining salt you can see which salt you will get, AlCl3. So again you have to balance this chemical equation, and I want you guys to balance the chemical equation because we have already done balancing of chemical equation in the first chapter, chemical equations and reactions. So this was when this oxide, this metal oxide is behaving and it is showing basic character. So now we know it can show both acidic and basic character. So let's react it with base now. So if you are reacting this oxide with base, it will show acidic character. So products, they are same, salt and water. So water you can write, and you have to see which salt you will get. It will be sodium aluminate. So these are the reactions of metal oxide with acid and base, and the reaction is very much similar to neutralization reaction. Next one is reaction of metals with water. So let's write the general chemical equation first. So if you react metal with water, we'll get metal oxide plus hydrogen. So these are the product. But you always have to remember one thing, we do have few metals which are soluble in water. For example, potassium, sodium, calcium and magnesium. So these metals, they are soluble in water. So for these metals you have to remember the metals which are soluble in water, they further react with water to form metal hydroxide. So you can write, you can complete this chemical equation. This metal oxide, further it react with water and it will give us metal hydroxide. The reaction is same. The only thing is this metal, instead of metal oxide, we'll get metal hydroxide. So let's perform this reaction. So like we have discussed, in case of reaction with air, different metals, they react differently. So same way, in case of water also, different metals, they react differently. So let's start with sodium and potassium. Sodium and potassium both are very reactive metal, and we have already learned that thing in reaction with oxygen. So sodium and potassium, both of them, they will react with cold water. Since they are soluble in water, so what we'll get, instead of metal oxide, we will get metal hydroxide in case of sodium and potassium. So here we'll get sodium hydroxide plus hydrogen gas, and same way here also we'll get potassium hydroxide plus hydrogen gas, and they are reacting with cold water. They can react with cold water. So this reaction, since they are highly reactive, this reaction again, it is highly violent, which can catch fire. So while the reaction with oxygen also, same case was there with sodium and potassium, they are highly reactive and they were catching fire. So there also we have discussed, due to being highly reactive, they are always kept in kerosene oil. Since kerosene, it forms a layer on the surface of the metal which cuts the contact with water or air, and which further prevents the reaction of sodium and potassium with water. After sodium and potassium, we know calcium and magnesium. These metals are also soluble in water. So being soluble in water, they will give us metal hydroxide. So it will give us calcium hydroxide. So this reaction, calcium, it can also react with cold water, and this is again exothermic reaction. Exothermic reaction means heat will be evolved, but the heat evolved is not sufficient to catch fire. So heat will be evolved in this reaction, but there will be no fire. Like we have already discussed, in case of potassium and sodium, they are highly exothermic reaction, and that heat, it will catch fire. But in case of calcium, it is able to react with cold water. It is also exothermic reaction, but there will not be any fire, because that heat generated is not sufficient to catch fire. So one more thing you have to remember in case of calcium, that this, it will start floating, this metal, it will start floating on the surface due to the formation of hydrogen bubbles which get stick to the metal surface. So hydrogen bubbles, they will get stick to the surface of calcium, due to which it will start floating on the water, on the surface of the water. Now let's discuss about magnesium. And we know magnesium is also soluble in water, and being soluble in water, it will again give us metal hydroxide. So we'll get magnesium hydroxide. But one thing you have to remember here, magnesium, it doesn't react with cold water. It reacts with hot water. Sodium, potassium and calcium, they react with cold water, whereas magnesium, it reacts with hot water, and it gives us magnesium hydroxide plus hydrogen. In case of magnesium also, magnesium, it will start floating on the surface of water due to the formation of hydrogen bubbles, and these bubbles get stick to the surface of the metal, due to which it will start floating on the surface. So both calcium and magnesium, they will float on the surface due to the formation of hydrogen bubbles which get stick to the metal surface. But calcium, it react with cold water, and magnesium react with hot water. So let's discuss about other metals now. So we have already discussed that all the metals, they react differently with water. So now we do have metals like iron, zinc and aluminium. So all these metals, they don't react with cold water. These metals don't react with cold water. These metals react with steam. So with steam they react. Steam is also water, but the water in the gaseous form. Iron, zinc and aluminium, they react with steam and they are insoluble in water. So being insoluble in water, we have already discussed, we'll get metal oxide instead of metal hydroxide. So let's do one reaction. So zinc, if you do so reaction will be same. You will get oxide of metal plus hydrogen gas, and the reaction it should be with steam. So zinc plus water. So here you can mention, because we are doing the reaction with steam, because this reaction is only possible with steam. So the product, it is metal oxide. So zinc oxide plus hydrogen. So as of now, I am just explaining you the concept. I am not doing balancing of chemical equation. Make sure side by side and along with me you are doing the balancing of chemical equations also. So all these three metals, iron, zinc and aluminium, being insoluble in water, will get metal oxide plus hydrogen gas. So the remaining metals, lead, copper, silver and gold. So these four metals, they won't react with water at all. So we have already discussed silver and gold, it won't react with air or oxygen. So these are the metals, lead, copper, silver and gold. They don't react with water at all. Now let's do the next property. This was all about reaction of metals with water. So before starting the next reaction, I just want to tell you, do watch this video till end, because I am going to share one trick with you to learn reactivity series. So now let's back to the reaction. Reaction of metals with acid. So this is very simple. Metal plus acid. So you will get salt plus hydrogen gas. So this is the general chemical equation. Any metal you can take and acid, HCl or sulfuric acid you can take. Iron, zinc, aluminium. So HCl if we take, so I just want you guys to do this reaction yourself. See, this is very simple. You will get one salt and hydrogen gas. So iron plus HCl, you have to see what you will get. So first one I will do for you, and these two you have to try yourself. So hydrogen gas, you know, it will be there. So remaining, which is iron chloride. Same way, zinc plus HCl, so you will get zinc chloride plus H2. Aluminium plus HCl, aluminium chloride. So just try to do the reactions and do the balancing of all these reactions. So this you can do. And the next thing is, you can also do these reactions by using sulfuric acid. If you do these reactions with sulfuric acid, you will get iron sulfate. In this case, you will get zinc sulfate, and in this case, because salt plus hydrogen you will get. So iron sulfate plus hydrogen, if you do this with, so here you will get zinc sulfate plus hydrogen gas. So aluminium sulfate with hydrogen gas. So just try to do this reaction yourself and balance these reactions. So one thing I have already discussed, I have only used two acids. First one is HCl and the other one is sulfuric acid. So this reaction, you have to remember, this reaction is not possible with nitric acid. It is not possible. So why it is not possible? Because nitric acid, it is a strong oxidizing agent. Strong oxidizing agent means this nitric acid on reacting, it will oxidizes this hydrogen gas. Since it is oxidizing agent, so it will oxidize hydrogen gas. If you oxidize means addition of oxygen. So if you add oxygen in H2, it will become water. So HNO being strong oxidizing agent, it will oxidize this hydrogen gas. So instead of hydrogen, water formation will be there. So due to which this reaction is not possible. But there we do have one exception, that with only two metals this reaction is possible. If you take magnesium and manganese. So this reaction is possible with nitric acid if you take magnesium and manganese, but the condition is that it should be very dilute acid. Dilute acid means if you are mixing water in this acid, so 98% should be water and 2 to 3% should be of this acid. So if the acid is very dilute, only then it is possible with magnesium and manganese. So with these two acids, you can take any metal and do reaction with these two acids, but with HNO3 or nitric acid, with only manganese and magnesium, this reaction is possible, provided this acid should be very dilute. So this was the reaction of metals with acids. Now let's do the next reaction. This is the last chemical property of metals, and this reaction is of metals with other metal salts. So this reaction is very much similar to, or we can say it is displacement reaction. Displacement reaction we have already done in the first chapter. So let's see what is the meaning of this reaction. So metal, if you react it with other metal salt, so we'll write metal salt. So I will write it as metal A, and this is metal salt. This is salt of metal B. So metal B salt I will write, or I can write this is metal A. We are doing reaction with salt of metal B. So it will give us, these are the reactants, it will give us salt of metal A salt of metal A plus metal B. So let's try to understand with one example. So metal I have taken zinc. So metal salt, let's take copper sulfate. See, this is a salt of copper sulfate. So if you see metal A, it is zinc, and metal B, it is copper. So you will get salt of metal A. So metal A is zinc, salt is sulfate here. So you will get zinc sulfate plus metal B. Metal B is copper. See, this is displacement reaction. This metal, it can displace this metal from its salt. So in displacement metal, you should know, in displacement reaction, you should know reactivity of the metals. Reactivity means only if this metal, it is more reactive. If this metal is more reactive than metal B, only then this reaction is possible. So you have to remember one thing, metal A, it should always be more reactive than metal B, only then this reaction will take place. So now let's learn the reactivity series in a very easy way. So I will write one short trick here. I know it's little funny, but once you see, you will learn reactivity series in 1 second. So I'll write the reactivity series first. So this is reactivity series. Till lead I am writing. We have some more metals after lead. So we'll learn till lead first. So I have created one mnemonic. So let's discuss that. K. So K you can learn by King. Na, which is sodium. So I have given the name Nathan. Ca. Calcium, can. Magnesium, make. Arts, A for aluminium, arts of zoo and forest, F for forests, and lead for P, PB is lead for P, I have written passionately. So you can see King Nathan can make arts of zoo and forest passionately. So if you learn these, you will come to know that K, it is for potassium, and for each of the first alphabet you can relate with the name of the metal. So the only thing is you should know the alphabet of the metal, you should know the symbol of the metal. K stands for potassium, Na for sodium, then Ca calcium, magnesium, aluminium, zinc, iron and lead. So you can see each of first alphabet K, N, C, M, A, Z, F and P. King Nathan can make arts of zoo and forest passionately. So you can learn this, and reactivity series automatically you can learn. So this is still lead, and now remaining elements we will write. It is after hydrogen now. So after hydrogen we have these 5 metals: hydrogen, copper, mercury, silver and gold. See, for these also another mnemonic I have created. So H for hungry people. So hungry people, C for can, H for have, A for apples and A for almonds. So this you can learn. Hungry people can have apples and almonds. You can see H for hydrogen, C for copper, H for mercury, A for silver and A for gold. So these two mnemonics if you learn, you can learn the reactivity series in the most easier way. So as you go down the reactivity series, the reactivity of the metals, it will decrease. For example, potassium is at the top. So potassium, it is highly reactive. Then sodium it is less reactive than potassium, but it is more reactive than calcium. So as you go down, reactivity it decreases. So below hydrogen, these are the least reactive metals. So in this way you can learn the reactivity series in the easiest way. And once again I will repeat it. King Nathan can make arts of zoo and forest passionately, and hungry people can have apples and almonds. So let's take aluminium plus calcium sulfate. So in reactivity series, aluminium it is metal A and calcium it is metal B. So I told you metal A, it should always be stronger or more reactive than metal B. You just have to see aluminium is here and calcium is here. So it is telling us aluminium is less reactive, because as we are going down, the reactivity is decreasing. So aluminium it is less reactive than calcium, which means this reaction is not possible. So now if I write in this way, calcium plus aluminium sulfate, then it will be this reaction is possible, because calcium it is more stronger than aluminium. So metal A should always be more reactive than metal B, only then that reaction is possible. And in order to know that, you should know the reactivity series. I have already told you this trick. You can learn the reactivity series by doing this trick. So with this, chemical properties of metals are finished, and in the next video I will do the related questions of chemical properties of metals. Thank you so much for watching the video. See you in my next one.